Okay, so in this video, I'm going to introduce the two fundamental structures in Pandas. So that's the Pandas data frame and the Pandas series. This is mainly going to be a recap of what we have already been looking at in assignment 0. So if you feel comfortable with the exercise in assignment 0, I suggest that you just skip this video and continue with the exercises in this notebook. However, if you didn't feel comfortable with the exercises in assignment 0, it may be a good idea to look through this video. Okay, but let's first just start out with loading some stuff. So here I'm loading some standard packages that you will see again and again. So first I'm importing matplotlib. That we will generally use this for plotting, and you will learn much more about this in session 4. Then I'm importing NumPy and Pandas, and then I'm also importing requests. Then we'll generally use requests for web interactions and such. Then finally, I'm also importing Seaborn. This can also be used for plotting, but it has also got some nice data sets that we can use to illustrate different features in Pandas. So that's mainly what we're going to use it for today. Okay, so how do we work with data in Pandas? So we use two fundamental data structures. So there is the Pandas series and the Pandas data frame. So let's cover each of these separately. So what is a series? You can basically think of it as a vector or a list with labels for each entry. So consider the following example. So here we have a list with 4 elements. Then I'm using the Pandas series class constructor on this list and create a Pandas series that I call my series. And this is basically what my series looks like. So we have default sequential indices here. We have data here. And then we have a specification for our data type here. So what are the components in the series? From before, we could see that a series consists of 3 components. So it consists of indices, so you can think of that as a label for each observation. Then it contains values or data really. And then it contains this D type, this data type. So that's the format of the series. And in the example from before, we had that the D type was object, which means that basically any data type is allowed. So there are also other data types. So that's, for instance, float, integer, and Boolean. So in terms of precision, we have that floats are more precise than integers, which are more precise than Boolean data. So Boolean data is basically just values that can only have a true or false value, while floats are numbers that can have decimal points as well. So in general, more precise data types are also slower to work with. So we want to work with as fast a data type as possible. So if we can work with Boolean data, we want to do that in general. Okay, so how do we set custom index? So indices, they don't need to have the sequential structure that you saw in the previous slides. And in order to see that, consider this example here. So first I'm creating an object called numData with this range function that I use to just generate data for this example here. Then I create a list that I call indices, which has 3 elements, 1 element associated with each data point that I will eventually get up here. Okay, and I call each of these B, C, and A. And then I use my Pandas series class constructor to create this object my series 2, which is a Pandas series. And here I specify that my data should be this numData object. And then I specify explicitly that I want my indices to be equivalent to this list here. And then what I get out of it is the following here. So you can see that these are my values. These are what I created with this range function. But then my indices are these. And you can see that there's no sequential structure here. So these are basically just indices that I have specified myself up here. What data structure does the Pandas series remind us of? So in general, it should remind us a bit of a mix of a Python list and a dictionary. And in order to see this, consider the following simple transformation. So here I have my series from before. That was the first series I created. And then I specify dot toDict. So this is a method that we can use to take our series and create a dictionary from it. So you can see simply by specifying this, we went from a pandas series to now have a dictionary where the keys are these indices, and then the values are 1, 1.2, ABC, and true. Can we also convert a dictionary back to a series? And yes, we can just put it into this series class constructor. So consider the following new example here. So here I create a dictionary that has 3 observations with associated keys: yesterday, today, and tomorrow. Then I'm just writing pandas.series, and then I'm inputting D, so this dictionary, and then I get this series out of it here. So I have these 3 indices: yesterday, today, and tomorrow, and then I have 3 values here as well. And now you can see that my data type is integer. Okay, so how is the series then different from a dictionary? So there is one important distinction to make. Series indices, they don't necessarily have to be unique. So consider the following new example here. So here I'm creating a new series that I call S, and the data is, I basically just have 3 observations, so that's 0, 1, and 2, but then all the indices are the same, they're all called A. Okay, so now let's see how many of these index values are duplicates, and the way that we check this is basically just to scan our series from top to bottom, and then when we check the first index, we can see that we have not seen this index before, so that gives us, we are given a false value here. But then when we get to the next index, and that's also called A, we get a value of true, and that's also the same for the third index here. So now when we translate our series S to a dictionary with the toDict method, we simply only have 1 observation, and that's just the last of these 3. So that's because the dictionary, it cannot handle observations with the same key. Okay, so now we know what a series is. What is a data frame then? So you can really think of a data frame as a 2D array, or simply a matrix with labeled columns and rows. And these rows are called indices, just like with the series. So consider the following new example here. So here we're using the pandas data frame class constructor and specify that we have a 2x2 matrix, which is our data, and then we want to have 2 columns called A and B. And we create a data frame called DF out of this. So this is what DF looks like. So we have 2 columns, A and B, and then we have these 2 sequential default indices here. Okay, so how can we really think about this? So there are these 2 simple ways of seeing the pandas data frame. So one is that we can see it as a NumPy array with some additional stuff. So now that we're with data frames, we also have names for our columns, we can name our indices, and we also get access to some pandas data frame specific methods. However, we can also see the data frame as a set of series that have been merged horizontally. And basically here in this data frame, every column, so every series in this data frame can have a different data type. So most functions from NumPy, they can also be applied directly to pandas. So we can convert a data frame to a NumPy array with the values attributes. That's what I'm doing here. I'm taking the data frame DF from before, and then I'm simply writing dot values, and then I get this NumPy array out of it. We see this is basically a 2x2 matrix. We can also see in Python, we can see the data frame as a list of lists, or sometimes a dictionary of dictionaries. In order to understand that, consider this example here where I'm taking my data frame, making it into a NumPy array, and then I make it into a list by specifying .toList. So here we see that I have a list with 2 elements, and each element we also have a list with 2 elements. So here we have a list of lists. Okay, so how can larger data frames be built? So here we can actually use this idea of representing the pandas data frame as a dictionary of dictionaries. So similar to series, data frames can be built from dictionaries, but an important difference is that when it comes to creating distinct columns, then data frames require that each value in the dictionary is also a dictionary. So consider this example here where I want to create a data frame that I eventually want to call my df1. So here I start out with having 3 different dictionaries, these 3, and in each of these dictionaries I have 3 values along with 3 associated keys. Now in order to create this data frame, I need to create another dictionary D that contains these 3 dictionaries along with some new keys, January, February, and March. And then I just use my pandas data frame class constructor on D, then I get my df1 out of it. So here we can see that every column here is basically one of these dictionaries that I had up here. Okay, so what then happens if keys are not the same? Actually, that's not a too big deal. So consider this slightly different example where in the March dictionary, instead of having the 3rd key, I have the 4th key, and then a value associated with this key. So now I just go ahead and create a data frame with the same approach as before. I call this data frame my df2. But now we can see here, now I have one additional row. So I have a row for the 4th, but because we don't have any key called 4th in January and March, I just get missings. I just get not a number values here basically. Similarly, also get a not a number value for the 3rd of March because also it didn't have an observation here. Okay, so that's actually, it's handled quite intuitively, I think. Okay, so we may now ask, how are series related to data frames? So we've already touched upon this, but putting it simple, then every column, we can think of that as a series. So consider the following example here where I want to access a specific column in a data frame with what I call a key-based approach. So I refer directly to the key, to the column name. So here I print column B in df, and I get the following out here. And we can see that the output is actually just like in a pandas series, right? We have values, we have these sequential indices, and then we also have the data type for this column. And then in addition, I also get the name of the column down here. We can also access a column using another approach, which you can think of as an object-based method. This can sometimes be smart, but it can also be dangerous. In order to understand that, consider an example here. But in this example, it works. So we want to print column B, so we just write df.b instead. We get the exact same output. But sometimes it doesn't work. So for instance, here we create a new column that we call count. Here we just specify that all the values in this count column should just be 5. And now my data frame looks the following way. So now let's try and use this object-based approach in order to access this count column. So here I write df.count, and then I get a weird output here. That's not what I expected. And the problem here is basically that count is also a method in my data frame, and that basically confuses pandas here. So be careful when you use this approach. You want to make sure that you don't have columns that share the name with a method. Okay, so we can also convert the data types in a pandas series with the asType method. So consider the following example here of how it works. So first I print my series 3, just to recap what this looks like. This was the dictionary where this was the pandas series that was created from a dictionary where I have three index names here, yesterday, today, and tomorrow, and then I have 3 values associated with these indices. Clearly my data type here is now integer. Now I want to make these values into float, the float data type. So how do I do that? That's fortunately quite easy. simply just use this as type method. I write dot as type and then np float. And then we can see that now I have decimal points and also have written here explicitly that my data type is float. I can also turn these values into strings. I just write np string here in this as type method, and then I get the following here. So from this output is actually not clear that these are indeed strings, right? But we can see it from the data type that now it's this object. Okay, so now we have talked a bit about pandas series and pandas data frames, and you may wonder, why don't we just use NumPy arrays and matrices instead? Isn't that easier? So there are several reasons why we don't always just want to use NumPy arrays and matrices. One key advantage of working with data frames is that inspection of data is just much easier, because now that we are able to name, for instance, the columns, it's much easier to tell what, say, in a large data set, what column 18 represents. So it may be quite difficult to say if you have a very big data set and it's basically just represented in a matrix without any column names. So now that each column has a name, it's quite easy to remember what each column represents. Also, if we change, if we delete some columns or add some new columns, these names just keep making it easy for us to sort of keep track of which columns represent what. Okay, so now that these data frames and series, they have indices, they may also contain fundamentally different data structures. So as we'll see later in this module, when we work with time series, for instance, it can sometimes be useful to let the indices represent the timestamp that's associated with a given observation. Indices can also contain other data structures, such as structures associated with spatial data, but that's not something that we're going to talk about in this course. And finally, when we work with data frames, it also facilitates some complex operations. So that's something that we're going to mainly see in the next session. So in the next session, we're going to try and merge different data frames. And we also try to use the split, apply, combine approach to making group-specific computations. So we can, for instance, find means within different categories in our data frame. And then finally, pandas also facilitates method chaining, which basically allows us to make multiple operations in a sequence, which can sometimes be extremely helpful. And you're actually going to see an example of that later in this module. Okay, so we may also ask, how can we view the contents in our dataset? So as we've already seen, we can use print, and then we get a view of our we can visually inspect our data set or our data frame. However, this is mainly useful when we have a small data frame. When we have a larger data frame or larger data set, we can also visualize the patterns in our data by using different plots. And we're going to talk more about that in module 4. However, when we plot, it gives us an idea of the patterns in our data set, but it doesn't necessarily give us an idea about the structure of our data set. So it doesn't give us an idea of which variables we actually have at hand and which data types they have. So what do we do when we have a large data set with many rows? How can we get an idea of the structure of our data? We can use the head and tail method, as we will see here. So in order to illustrate how these work, let's load the Titanic dataset that comes with the Seaborn library. So here I'm just importing Seaborn again, and then I create this data frame Titanic. And let's now inspect the first 3 rows in this new data frame. So that's actually quite easy with this head method. We just write Titanic.head, and then I specify that I want the first 3 rows here. So that's what I get. So that's a really nice procedure. We can also use the tail method that selects the last observations in the data frame instead. So instead of printing or accessing the first 3 observations, we instead access the last 3 observations, so we specify 3. Okay, so how can we select certain rows in a data frame using keys? So I'll show you that now. So in order to do that, we can use this log attribute that you're probably going to use a lot in this course. So in order to see how this works, consider an example here. In this example, I want to only access the values that are associated with the observations with index 0, 1, and 2. And also I only want to access values associated with variables survived, age, and sex. So how do I do that? I use this log attribute. So first I specify that I want to work with my Titanic data frame, and then I write .log and then these brackets here. So what I put here is now this range, which is basically treated as a list with values 0, 1, and 2 to refer to the three observations that I want to get access to. And then I specify a list here with the variable names that I also want to get access to. So that's survive, age, and sex. And this is what I get out of it. We can also select rows in a data frame using index integers instead. So we do that with the ilog method, which selects rows and columns for provided index integers. So that works the following way here. So this really, I think one way of seeing this ilog method is that it basically just treats the data frame as a matrix. And then here I just specify that I want observation 10 to 14. And then I just specify that I want the first 5 columns. So that's what I get here. But with this ilog method, we only use integers to refer to the values that we want to get access to. Okay, so are there other things that we should be aware of, other approaches for row and column selection? So one thing is that we can select rows for all columns by simply not specifying the columns. Or we can also just specify colon, and then we implicitly specify that we want to use get access to all the columns. So consider this example here, where I just want to access the first three observations, but I want to get access to all the columns. Therefore, I just don't specify any columns here. So that's with the log method. So we can also select certain columns and use all rows in our data frame by simply just specifying the column names here in these brackets. Okay. So that's ways of accessing all columns and only certain rows, or only certain columns and all rows. Okay, so let's now talk about modifying data frames. So why would we ever want to modify data frames? The fundamental reason is that data rarely comes in the form that we want it, and we need to sort of we often need to change the structure of our data frame. So one thing that we may want to do is that we want to change the indices of a data frame. So how can we do that? So here I'm just creating a new data frame that I call myDF, and I'm using this pandas data frame class constructor, and I first specify my data. So I want a 3x2 matrix of data with values 1, 2, 3, 4, 5, 6. And then I specify that I want my 2 columns to be called A and B. Then I also specify that my indices should be called I, and I. So these Roman numerals for 1, 2, and 3. Okay, so we can now change or set a data frame's index by using the setIndex method. So that works the following way here. So I specify myDF, and then I write .setIndex in order to use the setIndex method. And then I specify that instead of having these Roman numerals as indices, I want my column A to be the index. And what I get out is the following here. So now A, here the values in A is actually my index values, or my indices. And I basically only have one column with actual values in it, and that's column B. So doing this, we also implicitly delete the previous index. That's important to note. Okay, so we may now ask, doing that, is our data frame then permanently changed? Does it have a new index now? No, it doesn't. In order to permanently change our index, we need to make it into a, we'll generally need to make it into a new object. So consider now that I'm just printing my df again now, and you can see that it's not changed anymore. So when I did this thing here, it was just temporary. Now that I print my df again, it just looks like the data frame that I created. But in order to create to permanently change the index, I create a new data frame called mydfa, and then I basically just do the same thing as I did before. I write mydf, and then I use the setIndex method on column A. So now I have this new object, this new data frame that has this column A as the index, and that's permanent. Okay, so sometimes we also want to simply just remove the index, and that's possible with the resetIndex method. So now let's use mydfa from before. So let's use this data frame here, and then write .resetIndex in order to use the resetIndex method. So now I get the following here. So now I'm back at having these default sequential indices, and I have two columns of data, A and B. So now A has been made into a column with a column of data again. If I wanted to simply get rid of the old indices, I could have written drop equals true, and then I would have gotten the following here instead. Then I would only have column B with data, but I would be back at having these default sequential indices. Okay. So also, how do we change the column name? So column names can simply be changed with columns. So we write, in order to change the column names in mydf, this is what it originally looks like. I just write mydf.columns, and then I set it equal to this list with new column names. So doing that, you can see that we permanently change the column names in mydf. Now we have uppercase A and B instead of lowercase a and B up here. We can also just change specific column names by using a dictionary and the rename method. So here I write mydf.rename, and then I write columns equals, and then a dictionary with the column names that I want to change. So here I specify that I want to change the column with name A and instead call it AA with uppercase and lowercase a. And then in order to specify that I want this change to be permanent, I write in place equals true. And then my column, or my data frame, looks the following way. So now again, I have changed the column name as, here associated with the first column of data. Okay, so how can we update values in a data frame? That's fairly easy to do. So consider the following different examples here. So in the first example, first I just print what my df looks like. And then in the first example, I want to change all values in column B uniformly. And I want to set them all equal to 3. So I simply just specify my df and then B here equals 3. And then all of them are simply just equal to 3. We can also set different values, but then I have to specify a list with these different values. So because there are 3 rows in this data frame, I have a list with 3 elements, 2, 17, and 0. And then these are my new values for column B. Okay, so how can we update values in a data frame? How can we refer to specific values in a data frame that we want to update? So we can do that, for instance, with the log and the ilog method. In order to show how this works, consider the example here where I specify that I want to, in the data frame mydf, change the values associated with the row with index I and the row with index III, and I only want to change the value in column AA. And I want to set these equal to 10. So here I have my original data frame mydf, And here I have my new data frame where I have changed the values associated with row I and III, and only column AA to 10. So these two values here have now been changed to 10. Okay, and finally, we should talk about sorting data. So a data frame can be sorted with sort values. And this is a method that takes one or more columns to sort by. So again, consider the data frame myDF. This is what it looks like now. And now I want to sort it by column AA. And I want to do that in an ascending way. So I want to start with the lowest value, and then I want the values to be increasing. So I simply just specify ascending equals true. And then I got get the following here. Okay, so this is something that you're probably going to do quite a lot. You're going to use this sort values method. If we wanted to sort by multiple column names, we would simply just have a list here instead with different column names I want to sort by. And then if we also want to sort some of them in like ascending way and some of them should be descending, we would also have a list with the true and false values. Okay, and in addition, we can also sort by the index, and we simply just do that by using the sort index method instead. So that's what I'm doing here. So now we're basically just back at my data frame from before.